Okay, welcome to part 2. Newton's third law of motion is very important. For every action, there is an equal and opposite reaction. If I throw a baseball, 35 meters per second positive, the pitcher throws it, positive 35. The batter hits it back, over the fence, negative 100. Negative, opposite direction from the original motion, negative 100. The baseball applied a force to the bat, a positive force. The bat supplied a negative force to the baseball, went over the fence. Action, reaction. For every action, there is an equal and opposite reaction. Ball hits bat, bat hits ball. Okay, so very important. Newton's third law of motion. Collisions. There's two types of collisions. There is an elastic collision and an inelastic collision. An elastic collision. A Super Ball. I don't know what you call them now, but back when I was a kid, they were Super Balls. It was really kind of cool. And you drop it in it. It didn't come to the same height, but pretty close. That's an elastic collision where there's no loss of momentum, there's no loss of energy. The initial momentum equals the final momentum. It's perfect. It's an ideal system. No collision is perfectly elastic. When you think of elastic, you think of like a rubber band. Elastic refers to collisions. Collisions are either elastic or inelastic. A piece of Play-Doh falls down on the floor, doesn't bounce, completely inelastic. Completely. The energy was lost to the floor, it doesn't come back up. Inelastic. Elastic. There's no loss. I drop a ball and it comes back to the exact same height, ideally. Elastic, no loss of momentum, everything's perfect, everything's ideal, no loss of energy, nothing. Very important in chapter 9, elastic and inelastic collisions. Okay, enough said. This is change in momentum again, remember? Large F, small t, small f, large t, they're equal. Increase force, decrease time, everything's equal. Unsafe, not good. Safe. Why did I do that? Well, there's three basic relationships in the equation for momentum. Momentum equals mass times velocity. If you keep momentum constant, that doesn't change, such as here, that's a constant. I increase force, decrease time. Decrease force, increase time. They're indirect. Indirect. I keep mass constant. Mass doesn't change. Momentum and velocity. I increase the velocity, keeping the mass constant. I increase the velocity, I increase the momentum. Direct. Keep velocity constant, increase mass, I increase momentum. Great example. I have a truck. Unloaded. Light truck. Going 60 miles an hour. It has a momentum. Light truck, empty, 60 miles an hour. I load it full of things, full of widgets, full of everything. Very heavy now. Still going 60 miles an hour. Whoa. Increased mass. The velocity stays the same. Increased mass. Increase momentum. Direct. Yeah? Momentum in velocity, direct. Mass and velocity, indirect. Okay? Part 2. Have a great weekend. If I don't see you before Monday, have a great weekend. Bye.